here's a short tutorial on how we can use RStudio to calculate p-values from t-procedures, find critical values for t-distributions, and then perform a one-sample t-test using the command t.test. First, let's look at the command pt. This represents the cumulative probability that falls below some value from a t-distribution with a certain degrees of freedom. So in this example, I'm saying that I want to find the area that falls below a t-distribution with 9 degrees of freedom, and I want to find the area that is below negative 2.81. So if I run this line, I can see that that is equal to 0.010188 and so on. So if this were a test statistic and this were my degrees of freedom, then this is going to be my p-value for a lower one-sided test. Now, if I wanted to perform a two-sided test, then I could essentially just multiply this by 2, because that will give me the area that is more extreme in the tails for the lower tail and the upper tail. So a two-sided p-value would essentially be just 0.0204. Now if I want to use this pt command when I have a positive test statistic, so let's go ahead and switch this to maybe 3.4 or 3.5 or something like that, then what I'll get if I run this line is I will get a really large value. Well, this would be then the p-value for a lower one-sided test. But what if I wanted to do an upper one-sided test? If I want to find the area that falls above 3.5 in the t-distribution of 9 degrees of freedom, then I need to subtract this from 1, and this is more likely my p-value. So if I'm doing an upper one-sided test, I need to subtract the pt command, whatever I get from this, from 1. And so my p-value would be 0.00336. Now again, if I wanted to perform a two-sided test and I had a positive test statistic, then I need to multiply this by 2, and I'll get then a two-sided test, or two-sided p-value for my two-sided test. So here I get a p-value of 0.0067. All right, so that's how we can use the pt command to find p-values. We can also change the degrees of freedom here. So in this example, this is just 9 degrees of freedom. If we wanted to change this to something like 40, of course we can change that and rerun the section. All right, so if we want to find a critical value for a confidence interval, then what we use is 1 minus alpha over 2. So we use that proportion in the qt command, and then we define the number of degrees of freedom. So in this example, this is the 95% confidence interval or critical value for a t-distribution with 9 degrees of freedom. We find that the t-critical value is 2.262, and that is exactly what you'll find from a t-table. Now if I wanted to change this to find the 99% confidence interval, then I would need 0.995. Essentially, we're going to use the value that cuts off the lower 99.5% of the data from the top 0.05% of the data. Or in other words, 1 minus alpha over 2. If we want to change the degrees of freedom in this example, let's say we change it to something like 40, then we can find the critical value for a 99% confidence interval when the degrees of freedom are 40. We find that that's going to be equal to 2.70. So this is how we can then find critical values for any level of confidence that we're interested in and for any degrees of freedom. Now, if we want to then just do a one sample t-test, without having to do just finding the p-value or just finding the critical value, then we can run in our data. And in this example, this is the mileage data for a sports car. And we have 10 observations in this data. Then we can run in our vector of data, call it a name. So in this example, this is mileage. And then in the t.test command, we can then call up our data, that's going to be mileage, set up our null hypothesis. So we say mu is equal to 12,000. That's going to be our null hypothesis in this example. And the alternative hypothesis will then be two-sided. We can also change this to some other things as well, but we're going to keep it here as two-sided. And lastly, we need to put in our confidence level. In this example, we're just going to use the default 0.95. And if we run this, we get then the results from a one sample t-test. It's a two-sided test, so first we'll get our t-test statistic, our degrees of freedom, the p-value associated with this, and then the true mean not equal to 1200 is the alternative hypothesis, so it'll tell us that, and it'll give us our confidence interval. So this is awesome. Basically, it gives us all the results that we need. Now, if we want to just verify this, basically we can calculate our test statistic by doing this somewhat manually. So if we put in mean of mileage minus our claim of 1200, and we divide this by the standard deviation of mileage. So we basically are just here using the RStudio as almost kind of like a calculator. So this is our standard error. Let's go ahead and run this line. Oop, n, I put in n when really this is going to be 10. That's our sample size. And I get, again, a test statistic of negative 2.80635. If we scroll back up, we can see that's exactly what we got from the t-test results. So that's awesome. And then if we wanted to find our two-sided p-value, then essentially we see we can just say 2 times negative 2.806535 and put in our degrees of freedom of 9. And we should get the exact same p-value. We have to put in our command, pt. We'll get the exact same p-value that the t.test got. So if we roll up, we can see 0.02049. That is exactly what t.test got. So it is performing exactly how we should expect it to. All right, so let's go ahead and change a couple things up. Let's say we wanted to use this t.test. Let's just go ahead and copy and paste this down here. We could change this instead of to two-sided. We could change it to less than. And that will change a couple things. Command is less. See how it gave us an error? That's important that we're able to kind of read that. It's not less than, it's just less. And that will give me the lower one-sided p-value, because now my alternative hypothesis is that the true mean is less than 12,000. So if we see that we get then the same test statistic, same degrees of freedom, p-value is cut in half, our alternative changes, and also then the confidence interval that's been given is now just a one-sided confidence interval. So we don't really like to use one-sided confidence intervals, so if we do a one-sided test, then we should always still just do a two-sided confidence interval. So we can just do the two-sided confidence interval by performing the two-sided test and getting it from here, or doing it manually. So this is how we can use t.test to do different types of procedures, find our p-values using pt, and finding our critical values using qt. Hopefully this video helped you understand how we can use R for t procedures.